This is video assignment number 2, Jack Marchese. The date is October 24th. The question/goal is to maximize the total profit, determine how much of each product should be produced, and find the maximum profit. In this specific problem, a company manufactures 2 items which are sold in 2 separate markets where it's a monopoly. There are 2 quantities, Q1 and Q2, and there are 2 price functions, P1 and P2. P1 is equal to 600 minus 0.3 Q1, and P2 is equal to 500 minus 0.2 Q2. The company's total production cost is given by C. C is equal to 16 plus 2 Q1 plus 1.5 Q2 plus 0.2 Q1 Q2. The question is, determine how much of each product should be produced and find the maximum profit. Q1 is equivalent to the quantity of product 1 sold. Q2 is equivalent to the quantity of product 2 sold. As prices increase, the demand for each product decreases, which is a basic economic principle. This isn't really important to solving the problem, but it's just a good thing to note. The total revenue is given by R. R equals R1 plus R2, which equals 600 Q1 minus 0.3 Q1 squared plus 500 Q2 minus 0.2 Q2 squared. R1 is equivalent to P1 times Q1. You can see the work given there. R2 is equivalent to P2 times Q2. You can also see the work given there, which is how we solved for R. The total profit function is given by P, the revenue minus the cost. P equals R minus C. Insert the function for R, insert the function for C, subtract them, and then you will find P, the function for total profit. To find the critical points, we then take the partial derivatives of P with respect to Q1 and Q2, then set them equal to 0. For Q1, the partial derivative with respect to Q1 is 600 minus 0.6 Q1 minus 1.2 minus 0.2 Q2. For Q2, the partial derivative is 500 minus 0.4 Q2 minus 1.5 minus 0.2 Q1. We then proceed to solve the system equations. Subtract like terms to solve for Q1 and solve for Q2. You get 598.8 equals 0.6 Q1 plus 0.2 Q2. And then for Q2, you get 498.5 equals 0.4 Q2 plus 0.2 Q1. To eliminate Q1, we multiply the second equation by 3 to match the coefficient of Q1 in the first equation. Q2 multiplied by 3 is equivalent to 0.6 Q1 plus 1.2 Q2 equals 1495.5. You then subtract the first equation from the second equation to eliminate Q1. You can see the work done below, and then you solve for Q2 since Q1 is no longer in the picture. Q2 is equal to 896.7, which is a quantity number, not a dollar number. Now that we have Q2, we solve it into the original equation in order to solve for Q1. You can see the work done below. It's all worked through, and then Q1 is equivalent to 699.1. And then again, these are quantities of the product, not profit or any numbers like that. Now we substitute these values into the revenue functions so we can see how much revenue they make based off this amount of product sold. Product 1, you insert 699.1 into the revenue function. You end up getting 272,837.76. That is a dollar number. Product 2, you insert Q2 into the function. You end up getting $274,035.82. That's also a dollar number. Using these 2 revenue numbers, we also have to calculate the total cost before we can calculate the profit. Cost, you insert the Q1 and Q2 that is solved for above into the cost function given in the problem. You can see the work done below. Total cost is equivalent to $12,914.52. Calculate the profit using the P function. P is equivalent to R1 plus R2 minus C, which is also revenue 1 plus revenue 2 minus cost. You do the work below. You find out the total maximum profit possible is $533,959.06. Then again, that pretty much sums it up. It's pretty straightforward. You find the quantities, you find the revenue function, You find the profit function. You find the critical points. You solve the system of equations. After solving this system of equations, all that you do is substitute it back into original equations that you found, and then it's just a bunch of algebra to find the maximum profit. Thank you.